Good morning. Welcome to the second experiment on data structures. So, our second experiment is operations on strings in C language. So, that is the title of our experiment. Now, before performing the operations on string, you should be aware of some concepts in C language. So, the prerequisites of this experiment are basic programming constructs in C language, then you should be aware of data types in C language and arrays. Okay, so these are the prerequisites. Now, objective of this experiment is to learn these operations on strings. So, what are those operations? First, substring. Second, palindrome. Third, compare. Fourth, copy, and fifth one is reverse. So, we have to perform these five operations on string. And the expected outcome after performing this experiment is you will be able to use strings in a C program. Okay, so you will be comfortable to use strings in a C program, and you will be comfortable to perform the required operation on string. Okay, so a student will be able to use strings in a C program and perform the required operations on them. That is the expected outcome from this experiment. Now, before going to a program, first we will look at some theory background of the string. So, if we define a string, then it is defined like this. So, string is a sequence of characters which is treated as a single data item. It is a sequence of characters treated as a single data item, and the string is always terminated by a special character which we call as a null character. So that is the last character of each string. So that is the definition of string. Now in this definition, this is important, single data item, because a group of characters can also be called as array of characters. If it is only a group of characters, it can be also called as array of characters. But every array of characters is not a string. If that array of characters is terminated by null, then only it becomes a string, and then only it can be used as a single data item. Okay, so that is the difference between array of characters and string. So string is a single data item, and only array of character cannot be treated as a single data item. Single data item means you can perform all the operations, all the standard functions you can implement on a string if it is a single data item. Okay, now how that string is stored in a memory. So this is the picture which is from inside a memory. So string is stored like this. Okay. Now in this example, S is the name of string. In this particular example, S is the name of string. And size of this string is 6. Means there are 6 locations in the string. Okay. And what are the values stored in those 6 locations? First value is A, second is V, then C, then O, then E, and last character is null character. So that is the termination. So AVCOE, that is the abbreviated name of our college. AVCOE is the value of string. Okay, and addresses of these individual elements are: first address, that is the starting address of the string, is suppose 1000, then obviously second address will be 1001. Why? Because we are going to store characters, and character requires only 1 byte. Okay, so if 1000 is the first address, then second address, that is the address of second element, will be 1001, then third will be 1002, then 3, then 4 and 5. So these are the addresses of individual elements of a string. Now suppose we have to access a whole string together. Okay, if I have to access a complete string, then I will access it by its name, that is S. Okay, because S is the name of string. But if I have to access, if I have to access a single element of a string, individual element of a string, then I have to use index. Okay, so first character or first element of string is designated as s of 0. It is called as s of 0. So s of 0 means first element of string. S of 1 means second element of string. S of 2 means third. Then S of 3, S of 4 and S of 5. So these 0, 1, 2, 3, 4, 5, they are called as indices. That is the index of each element. This concept is similar to array. In array also there is an index. Okay. So S of 0, S of 1, S of 2, S of 3, S of 4, S of 5 are the individual elements of a string. Okay, so if I have to access a whole string, I will access it by its name, that is S. And if I have to access only a single character at a time, then I will use index. Okay, okay. Now, if I have to use a string, if I have to use a string in a program, first I have to declare it. First, I should declare the string. So what is the syntax for declaration of string? The syntax is very simple. Data type, that is char, because string is sequence of characters. So data type will be character only. So char, then name of the string, that is given by the user. User may select a name by his own choice. Okay. So char space name of the string, and in bracket we have to specify a size. Char name of string size. This syntax is similar to the array. The only difference is in array this data type may change. If it is an array of integers, then it will be a int name of array and then size. If it is array of character, then here char. If array of float, then float. But in a string, it is compulsory sequence of characters. So this term or this quantity will be char. So char name of string in bracket size. For example, char s of 6. Char s of 6. Okay. So s is the name of string in this example and 6 is the size. Means there are 6 locations in this string. So the above example A B C O E, 5 characters and 1 null character. So total there are 6 characters. Okay, or 6 locations. So that is about declaration of string. Okay. Now next, how to read a string. How to read a string or how to store a value in a string. So there are two methods like a normal variable. There are two methods. One, compile time initialization, that is giving a value at compile time, and second runtime, and second is runtime. Now first we will see compile time. Compile time means in a program itself we store some value. In a program itself we store some value, that is called as compile time. So this value is available when we compile a program, that's why it is called as compile time initialization. So compile time initialization of a string is done like this. Suppose I declare a string like this, char s of 6, and in the same statement I can initialize it like this, equal to in double quotes abcoe, in double quotes abcoe. Okay, so abcoe will be stored inside a string having a name as s. Okay, and in this particular example, null character is appended at the end of string automatically by a compiler. So compiler will take care of it. Compiler will store null character at the end of string. This one. Okay, in first example. Now second way of compile time initialization is we can separately store individual characters, that is A separately, B, C, O and E, and they are written in curly braces. This is called as curly brace. Okay, so in curly brace we can store A, then V, then C, then O, then E, and now this is the responsibility of programmer to store null character at the end. It is not appended or it is not stored at the end of string automatically. Programmer has to do this. Okay, so we have to explicitly write null character in this sequence. Okay, and as we are writing here single character, so they are enclosed in single quote. They are enclosed in a single quote. In the first example, it was complete list of character ABCD. So there were 5 characters. So they are enclosed in double quotes. Okay. So in second method, we can write separate characters separated by comma. Okay. Now third way is we can skip the size. Okay. Without writing a size of string, we can initialize a string. In this particular example, the size of a string is automatically handled or automatically calculated by a compiler. Compiler will allocate a proper size automatically according to the input. Okay, so compiler will automatically allocate 6 bytes to this string because there are 6 characters, 5 ABCY and last null. Okay, now some modifications are there. See the fourth statement, char s of 10 equal to abcd. So what is here, the thing to be noticed is we have declared a size as 10, but we have stored only 5 characters and 6 one will be null character. So we are using only partial part of a string. So this is allowed in C language. Okay, char s of 10 equal to abcd, this is allowed. But if we do reverse, reverse means input is larger and the defined size is smaller, then this is not allowed in C language. You will get a compile time error. You will get one error. Okay, so if I write char s of 3 equal to abcy, this statement is not permitted. This statement is not allowed in C language. Why? Because we are defining a size as 3 and we are giving the input characters as 5 and 6 1. 6 will be null character. So we are allocating 3 characters, that is the 3 bytes, and trying to store 6 characters. So this is not allowed. Okay. Next thing that is not allowed is we cannot separate declaration and initialization. We cannot separate declaration and initialization. These two things to be done in one statement only. Like this, char s of 6 equal to abcd. This one is allowed because where this char s of 6 is the declaration and equal to abcy is the initialization. So these two things must be combined in a single statement, then only it is allowed. But if I separate it like this, char s of 6 is only declaration and then s equal to abcy, that is initialization. So this is not allowed. Okay, so they must be combined. Next modification is, now suppose I declare and initialize one string like this, that is char s1 of 6 equal to abcy. This is allowed. Okay. Now I declared a second string like this, char s2 of 6. So this is declaration. And now if I try to copy s1 string inside s2 string using the statement s2 equal to s1, this statement is not allowed. Okay, so assigning a string to another string directly using equal to symbol is not allowed in C language. This is called as assignment operator. So using assignment operator, if you are trying to copy one string into another string, then this is not allowed. Okay, so again we will revise. We have to combinedly do declaration and initialization. Char s of 6 equal to abc, this is allowed. In that case, null character is automatically added by a compiler. Second, char s of 6 equal to a separate, b separate, c separate, o separate, e separate, and in this case programmer has to write null character at the end. It is not done automatically. So this is the second way. Third way, we can skip a size. In that case, the size is automatically calculated by a compiler. Next, if size is greater and number of characters are less, this one is allowed. But if size is less and number of characters are more, then this is not allowed. Next, char s of 6, that is the declaration is done separately and initialization is done separately, then this is not allowed. They must be combined. And last one, if you are trying to use assignment operator to assign one string to another string, then this is also not allowed in C language. So this is about compile time initialization of a string. So we will just do one small program here. So here, so these lines are already typed to save time. So hash include stdio.h, audio.h. These two header files are included to our program. Then main function is started. So first we have declared one string char s of 6. Okay. Then clr ser and get ch. Now if I initialize a string like this, char s of 6 equal to abcoe. Save the program and compile it. So this is without any errors. There are no errors. See, there is a warning because we are just storing a value in S, but we are not using anywhere. That's why this is the warning. See, warning is S is assigned a value that is never used. So right now, ignore this warning. Just concentrate on the first statement of main function, that is char s of 6 equal to abc. So this is allowed. We have not encountered any error for this statement. Okay. Now if I do like this, s of 6 equal to a separately, b separately, c separate, then o, comma, then e, then comma, and then null character. Null means backslash 0 is called as null character, and then curly brace complete and semicolon. Now again I will save the program and compile it. So again we are getting zero errors. Ignore the warning. Just look at errors. Zero errors means this is allowed. Okay. Now if I do like this now, suppose, okay, size is kept blank. Save the program and compile it. So again zero errors means this is allowed. Now suppose size is more and number of input values are less. So means 10 is the size here and number of characters are only 5. I will save it and compile. So again we are getting zero errors. So this is also allowed. So only 3 is the size and we are storing more than 3 characters. So here we are getting error. See, there is one error. So what is error? Too many initializers. Too many initializers means we are exceeding the limit, right? Because we have given a limit, that is we have declared a size as 3 and we are trying to store 5 characters. So this is not allowed in C language. Okay, so this was just a demonstration of the compile time initialization in C language. Now you can try out this also, that is initialization and declaration separately, then assignment operator to assign one string to another. You can try at your own. Okay, so this is about compile time initialization. Now second way of initialization of a string is runtime. Okay, so we will do a runtime initialization now. So there are four ways to do this runtime initialization. So what are those four ways? First one, using scanf function with %c as a format specifier, because %c is used for a character. Okay, so using scanf with %c, that is the first way of doing runtime initialization of string. Now the limitation of this first method is 1%c can read only one character. 1%c can read only one character. Now, if I have to read a string of 5 characters, then I have to use 5 times %c, or I have to use for loop or any loop which will run 5 times. And second limitation is null character is to be added by a programmer. It is not done by a compiler. Let's say for example, suppose I have to store 5 characters in a string of name s. Now suppose string is declared initially, we will assume it as char s of 6. Then I have to write like this. %c, %c, again %c, again %c, again %c, and then comma and s of 0, comma and s of 1, again comma and s of 2, again comma and s of 3, comma and s of 4. So like this, and then I have to add explicitly null character s of 5, s of 5 equal to null character. See, like this. If I have to read a string of 5 characters using scanf with %c, then I have to do like this. Scanf %c, 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 %c 5 times, and then and s of 0, comma and s of 1 and s of 2, 3, 4, like this. Or we can use a loop like this. For I equal to 0, I less than 5, I plus plus, and then scanf %c, comma and s of I. Okay, either like this. Okay, one more thing. Or you can write I also here. So either like this, that is 5 times %c, or using a loop for I equal to 0, I less than 5, I plus plus. So this loop will run 5 times, and every time value of I will be different. Initially I will be 0, so here %c and s of 0. So first character will be read from a keyboard and it will be stored into s of 0. Then for the next iteration I will be plus plus, so it will become 1. So second character will be read and it will be stored into s of 1. Then again plus plus, s of 2, and s of 3, and s of 4. And when I becomes 5, this statement, that is this condition, becomes false. So it will come out of a loop and it will execute this statement. So how it will execute? S of 5 equal to null. Okay. So either this way or this way. Okay. Both are one and the same. But what is the limitation here? Every time you must know the size of string. There is another way also. You can type enter key at the end of string, and that you have to mention explicitly in a program that press enter key after the end of string. You can handle in that way also. Okay, but this is not a easy way of accepting a string at runtime. Okay, so mostly this method is not used to initialize a string at runtime. Which method? Using scanf with percentage. It is not mostly used. Okay. Now second way is using getChar. Now it is like a first method only. The only difference is function is different. In the first method we are using scanf, and in the second method we are using getChar. GetChar also means get a character from keyboard. So you can do like this. See, for I equal to 0, getChar. So what does it mean? Get a character from keyboard and store it in S of I, and I will be different for each iteration. So at the first time I will be 0, so get a character from keyboard and store it in S of 0. Then I will be iterated to 1, so it will be increased to 1. Then again get a character and store it in S of 1. Then again plus plus, so it will become 2. So get a character, store it in S of 2, then S of 3, then S of 4. And when I becomes 5, condition becomes false, and then it comes out of the loop, and then S of 5 equal to null. So first two methods are nearly same, only the function that is used is different. In first case it is scanf, and in second case it is getChar. But both these methods are not generally used. Okay, so concentrate on next two methods, that is using scanf with percentage and using getS. So what is the syntax of writing scanf with percentage? So syntax is very simple. Scanf percentage comma, and here you have to specify name of string. Syntax is very simple. Scanf percentage double quote complete comma name of string. Now one point to be remembered here is ampersand, that is address operator, is not required here, because mostly whenever we use scanf we have a habit of using AND operator here. AND means address, but in this case it is not required. Now why it is not required here? The reason is whenever array or string is declared, then name of that array or name of that string is automatically declared as a pointer by a compiler. The name of the string or the name of that array is automatically declared as a pointer by the compiler, and that pointer stores base address of the corresponding string or corresponding array. Means when we declare a string like this char s of 6, suppose I declare a string as char s of 6, then the name of string, that is s, automatically becomes a pointer inside a memo, and this s stores starting address, that is the base address. So s itself is a address. That's why here AND is not required, because name of string is by default an address. Therefore again that AND operator is not required here, because name of string is by default an address. Okay, so that is the thing that to be remembered. Scanf percentage name of string. Example is very simple. Example is scanf here percentage comma s. S is the name of string. Now in all the above examples we are using s as a name of string. Okay, but it is not compulsory. You can give any name according to your choice. For simplicity, for a string I have given a name as s. You can give a b c d or any meaningful name according to the required application. Okay, so scanf percentage and name of string is s. It is very simple. Okay, but and the advantage of using this method is it can read any number of characters. More than one characters can be read by this function. In first two methods there was a limitation because one percent %c can read only one character or one getchar can also read only one character. That's why to read a string having multiple characters either we have to use this many times percent %c or we have to use a loop, and same is for getchar also. Okay, because single getchar can read a single character. So if I have to read multiple characters I have to execute this getchar multiple times, and for that multiple times execution I have to use a loop. So that was the limitation here, but this limitation is not there in third method. Using 1% you can read any number of characters. Okay, so that is the advantage you can say as compared to above two methods. So what is the advantage? It can read any number of characters. It can read any number of characters in a single statement. But there is one limitation. There is one limitation, and limitation is it cannot read white space. That is the limitation. It cannot read a white space. White space means if there is a separation between two characters in a string. Suppose I have to store a string like this. Suppose I have to store a string like this. Amrut Wahini College. Amrut Wahini College. Then I cannot store this string using percentage because in between Amrut Wahini and college there is a space. So this space cannot be accepted by using percentage. And whenever such white space appears in an input, that string is terminated from that white space. Is it clear? That is limitation of the string. Sorry, that is the limitation of this scanf with percentage. What is the limitation? It cannot read white space. Okay, and advantage is it can read any number of characters. Okay, now we will see all these concepts in a program later on. First we will see the last method. Now using getS. So it is the best method for reading a string at runtime. The syntax is very simple. GetS means get a string and inside bracket name of string. Very simple. GetS in bracket name of string semicolon. For example, getS in bracket s. So syntax is also simple and it doesn't have any limitation also. GetS in bracket s. So it can accept any number of characters and it can accept even a white space also. So this input Amrutwahini College can be stored using this one getS, but it cannot be stored using scanf with percentage. Okay, up to Amrutwahini it's okay because there is no space. But if there is a space, then this function fails. It gets terminated from that instant, and only the previous part, that is Amrut Vahini, will get stored in a string. College is skipped, but using gateys this thing is possible. Okay, so these are the four methods for runtime initialization of a string. Okay, now we will end here and we will see the remaining part in next video. Okay, thank you.